We're going to approximate the square root of 65 by using linearization of this function of y equals the square root of x. So linearization is another word for saying the equation of the tangent line. So we're going to find the equation of the tangent line. So first thing I'm going to do is I am going to find my derivative of x to the 1/2. So the derivative is going to be 1/2 x to the negative 1/2. So I'm not going to have a dx in this because I'm not talking about taking the derivative with respect to time. I'm actually taking the derivative with respect to x. So in this case, since we're trying to find the square root of 65, the closest number I can find for 65 would be 64. So that means that y would be 8. So when x is 64, y is 8. So that's what I'm going to use. So I'm going to go ahead and substitute x. So I'm going to have 1 over 2, the square root of 64, which is 1 over 2 times 8, and that gives me 1 over 16. So I'm going to go ahead and write this in point slope form, and I'm going to solve for y. Okay, so if I do that, I end up getting y equals 1 over 16x plus 4. Okay, so here's my linearization, and I'm going to use that to approximate this when x is 64. So I'm going to substitute 64. So y turns out to be 0.0625. So that is my approximation. The actual, which it doesn't ask us to find the actual, but the actual would be 8.06225. So we're really close to the approximation. In part B, it's asked us to approximate the square root of the cube root of 65. For this one, they don't give us an equation, so we're going to have to come up with the equation ourselves. So it's going to be the cube root of x. So in this case, x would be 64. So that means y is 4. That is the closest approximation to 65. 4 to the third power will give you 64. So 64 to the 1/3 power gives you 4. So we're going to go ahead and take the derivative. So this is similar to part A. We're going to take the derivative. So that's going to be 1/3 x to the negative 2/3. So I'm going to go ahead and substitute x, which is 64. So the cube root of 64 is 4, and I'm going to have to square it. So I have 1 over 3 times 16, which would be 1 over 48. So then I'm going to use point slope form. And solve for y. So I end up with y equals 1 over 48x plus 8/3. So here's my linearization. So I'm going to use that to approximate this, the cube root of 65. So notice that I substitute 65 into my x, and that turns out to be 4.0208.